Welcome back. For this question, you've been thinking and trying to solve this quadratic equation. Quadratic equation is very important because we can solve some real life problems using quadratic equation, and it's good to know how to solve. Maybe I think I have opened some quadratic equation formula. I can just make it bigger here. Maybe I can just do this way. As you can see, every quadratic equation do have three coefficients, A, B, C, and it's a second degree. Second degree means this is a square. So x square, this usually should be x square. So at least something to be called a quadratic equation, bx plus c is equal to 0. So this is a proper quadratic equation, and we have a coefficient a, b, c, as you can see. So this could be written, for instance, in the case of a, if it is 1, x squared plus 2x plus 1. So now the value of a is 1, the value of b is 2, the value of c is 1 again. So this is a proper quadratic equation. In quadratic equation, we get two solution set. Different solution set. It could be two solution set, or it could be one or no solution set. Okay, if this b square minus 4ac is equal to 0, then it will have one solution set. If b square minus 4ac greater than 0, it will have two solution sets. If b square minus 4ac less than 0, no solution set at all. So you don't have to know manually how to calculate. There are formula. The formula is like this: b square plus or minus b and under radical b square minus 4ac divided by 2a usually gives you the solution set. So when you calculate this, once you make this only plus, and in the second case, you make this minus. Yeah, one case plus, in the other case minus. So now let's start. And maybe I think it's good to call this file name. Maybe I can call it later quadratic equation. So now let's say, for instance, we have this function. I may just give you x squared plus 2x plus 1. So this one is actually another way you can write this: x plus 1 and x plus 1. And the solution set is going to be x is equal to minus 1. So it has one solution set. If we have x squared plus 3x plus 2, this will be written another way. It could be written x plus 2 and x plus 1. And the solution set is going to be x minus 2, x minus 2, and x minus 1. If we have another solid, so x squared plus 2x plus 3, we may not have a solution set for this. So we will see, we may or may not, but I don't know. I have to use the discriminant. What is that, the discriminant? B squared, this b squared. How do I make b squared? So I can use b squared minus 4ac, right? So this is discriminant. So I call this discriminant. Okay, so let's see if this is going to be, what's the value for this? Let's check. Then I have to check. So if I have that, so we follow this, this pattern as I showed you, okay? So I can say what's b in here? 2. Then square and minus 4. A here is 1, right? Times C. C is also 1. So as you can see, 4 minus 4, it's going to be 0. So it's going to have one solution. So it was right. Oh, great. Now let's try for this one. What is A? A is also 1, but B square, right? B is 2 to the power of 2, 4. For A, 1, C is 3. So now as you can see, we have 4 minus 12 minus 8. It's less than 0. So this one doesn't have a solution set. Of course, it may have, but it will not be a real value. Yes, Elena. Yes, we are solving problems, and this is yeah. Oh, okay. So this is the discriminant. So as you can see, we can make use of this. Yeah. So, but this is also some part of the formula. If I show you, b squared minus 4ac. Yeah, this is some part of the formula. So we can say def solve quadratic. Since this is a solve to question A, B, C, and then I can just say the discriminant. I can put this one, or I just have it already. Then I can do a logic as Johnson did. If the discriminant is greater than 0, I will have two solutions. Else, if the discriminant is equal to 0, I will have one solution. Else, I will not have anything. Yeah. So then let's do. Then how do we calculate solution set here? As you see, minus b plus or minus. So how do I write? Minus b. I can start with the plus. And then this part under radical. So how can we do that? I can say discriminant. And then if I just do this 0.5, that's the power. And then I can again do this, enclosed and divide by 2a. Oh, then 2 times a. And this is one of the solutions. So you can call it x1 or solution 1. And to calculate the second, actually, it should be x2. And in this case, instead of plus, I should do the minus. And I like actually spacing. And now we can just return x1 and x2. Yeah, then I'm now writing like JavaScript here. It should be elif. Okay, great. And we can go here again because there's some similarity in the second part also. And I can modify it from there. But in the second part, since, as he said, this part is going to be 0. This part is going to be 0. So we will have only minus b over 2a. So we don't need this part at all. Which part? This part. Yeah, then we will have that. So this our solution set also is going to be just 1. For some reason, there's some indentation problem. Okay, else return nothing. So we are returning nothing, and that's going to be an empty set. Just to check now, print solve the quadratic equation, and if I have 1 and 3 and 2, let's see the value for this. One and -1, yeah, that's good. Oh, great. And if you just check, also 1, maybe here 2 and 1, I'm just expecting 1. Yeah, great. Yeah, this is my solution for the quadratic equation. I hope you got it, how to solve it, and you got the idea. Yeah, I think it could be written in a different way, but this is one simple solution. As you guys mentioned also, you can use this 0.5, or you can also use import from math, and this math from, I think I can say, from math import sqrt. And now, instead of doing this, you can also do square. Actually, sqrt. Yeah, let's see and see the solution. Yeah, the same value we got. Okay, great. You can use this or the other, it doesn't really matter. And let's just give it this also a new name, and we can call it quadratic equation. Equation.py. In case if you want to refer, you can identify it without any problem. So let's finish the quadratic equation part here.